Hello everyone. So in our last lab we have understood to digitization of the river and terraces. So today we will continue from the same lab, and today we will trace some more geomorphological features. So here you can see, so in our last lab we have traced the different level of fluvial terraces and the river system. So now today we will add some more geomorphological features. So here you can see this is the alluvial fan surface, and this alluvial fan surface has been deposited by this river. So this is the river called the Gola river, and this all the sediment has been deposited by this river. So you can trace a different level of alluvial fan surfaces also. So to trace the alluvial fan surface, similarly you have to create a new shapefile named the alluvial fan surface, or you can save it as AFS, that is alluvial fan surface, and you assign the directory, and the geometry would be your polygon and with the same EPSG 4326 and WGS 84. So you can similar to the terraces, you can add a new field in which you can assign the different level of alluvial fan surface. So it say the alluvial fan surface is also deposited as your in a different phase of river depositions. So you can trace all those different phase of deposition as a separate fan surface. You can mark those layers as a separate fan surface. So you can here assign a new field that would be your type of fan surface, and the that is in text format. You can assign the length of the word, and you click on the add to the field list. So here you can see your new field has been added, or you can click on OK. So on the layer panel you would see a new layer, that is your AFS alluvial fan surface has been added. Now you can start the digitization part by the toggle editing option, and here you can see your a symbol with this editing toolbar. You can trace your fan surface. So when you will use this your 3D glass, because this is a anaglyph, so you can use your 3D glass to get a 3D representation of the surface. So here you can see that this part is a youngest fan surface. So you can mark this part as a youngest fan surface, or you can start from the AFS 0, that is similar to the similar as we did in case of terrace. So here you can also mark this one as a AFS 0. So to start the your digitization, you have to start from one bank of the AFS, and you can trace the bank or the outer part of the fan surface. So you can trace, and the another bank you have to trace the another bank of the fan surface. And once you completed your tracing part, you right click on your mouse, and you assign a random ID number, and this one is your youngest fan surface. So I will write it as a AFS 0. So this AFS 0 means the youngest fan surface. So here you can see your AFS 0 has been here you can see the AFS 0 on your screen. So now you on your layer panel, because your river is just below the your AFS, that's why this here on the screen you are seeing the AFS above the river. So you can simply drag your river over the AFS. So now here you can see the river is flowing over your AFS. So similarly you can trace the another level of fan surface. So you use your digitization tool, and here you can see these all are part of the alluvial fan surface. So this fan surface has been deposited over the time by the sediment deposition which is brought by the river. So you can simply trace all this part. So this is a large alluvial fan surface, and this fan surface has been formed by the sediment brought by this river. So you can trace all the part of this fan surface. So this tracing part you have to do it very carefully to generate a precise geomorphological map. So now I completed with the tracing part. So now you can assign a ID number, and this one is my AFS1. So I am writing it as a AFS1. So here you can see your AFS1, a part of AFS1 has been generated over here, and this part is also the alluvial fan surface 1. So because these are at the same level, at the same height, so you can categorize it as a AFS1. So now I will trace the remaining part of this fan surface. So you have to start from here. So these are all part of your alluvial fan surface. So again I am telling you that this tracing you have to do it very carefully. For demonstration purpose I am doing it very vaguely, but you have to, while you are generating your own map, that time you have to spend some time to digitize all these geomorphological features, because that will ultimately give you a precise or accurate geomorphic map. Here I am giving you a demonstration to how to digitize the different geomorphological feature, and when I completed with this demonstration part, then I will show you that how a Tectono-Geomorphological map looks like, which we have did for our research point of view. So that map I will show you. I will open all the shapes file and I will give you a view of that how your Tectono-Geomorphological map is looks like. So here this one is also your AFS1. So now when you completed with the digitization part, you click on the save, because all the vector file which you have to generate, you have to save save it also. So when you will go to your attribute table, here you can see three ID or the three vector file you have generated, but here on the layer on your screen you can see only one color is showing over here. So you can categorize this different AFS surface through your properties panel. So you go to your property panel, or over your property panel you can see. So you can change this at the categorize. So when you are in categorize panel, so here you have to assign the value, which value you want to categorize or differentiate. So here it is the type, where I have mentioned the different type of fan surface. So you can simply classify this type. So here you can see this two type of fan surface I have digitized. So here you can see AFS0 and AFS1 has been marked. So you can apply, or here you will see your different color for your AFS. So you can change the color also by going to the color chart. So here you can choose a color, or you can apply the color. So here you would see that a new color has been assigned to your AFS 0, and similarly you can also change your AFS 1 also. So here, so now here you can see the color has been color is also changed. So similarly you can digitize your your different fan surfaces as well as the terraces, the river system, drainage pattern, all these geomorphological feature you can trace, and you can also trace the tectonic features, that would be your fault or all kind of this tectonic features also you can trace by this digitization process. So, till now we have shown you that how you can trace different geomorphological features with the help of polygon tool. So, now we will trace some features which we will use as a the line tool. So, as we know that the fault is a kind of linear features. So, we will when you are tracing the faults, so you have to select as the line as your shape file. So, now we will trace the fault. So, in our last lab, so I have explained you that how you can identify the tectonic features. So, here for example, here you can see when you use your 3D glass and you will see this high resolution anaclave. So, you can see over in this area. So, this area some topographical warping you can see over this area. So, this topographical warping is basically generated due to the faulting. So, this block is moved over this block. So, this is your Shivalik hills and this is your Indo-Gangetic plain, but in this area you can see that this fluvial deposit, the quaternary sediment, is also warped, or it is this portion, this is the toward the northern part and this is the southern part. If you use your 3D glass, so you will see that this is at a different elevation and it is at a lower elevation. So, it is basically at a height compared to this part. So, this is in structural geology, this type of features are generated when you are in a deep slip environment. So, this block is been overriding, this block is basically moving on this block. So, this is basically kind of scenario where this was your surface and then a faulting event has occurred. So, if suppose this is your fault and if this is your north direction and this is south direction. So, your fault is suppose in dipping in north direction, and due to this movement of this fault, this block is just overriding on this block. So, this part which is moving, so this is called your hanging ball and this one is your football. So, in this image you can see that if we consider this is as a thrust environment, so this would be your football and this one is your hanging ball. So, so you can identify this type of structures and you can trace the your fault. So, to trace your fault you have to generate a new shape file. So, you go to the layer panel and you generate a new shape file. So, suppose I want to trace the fault. So, I will name it as faults. So, and then from the geometry type, because fault is a linear feature. So, you have to select the line as your vector file. Earlier for the river terraces, for the and the alluvial fan surface and the river, we have chosen the polygon as our vector file, but to trace the linear features, for example to trace the fault, you have to choose line for your vector file. So, we will choose the line and then you can also add the type of your fault. For example, you are able to identify different type of fault in your selected image or in your area. So, you can categorize those fault based on the sense of movement or the environment. So, for example, if in your area or on your image, if you can identify the dip slip fault or you can identify the strike slip fault. So, you can categorize those fault with adding a new field. So, that could be your type. So, in type you can assign whether it is a dip slip fault, or in dip slip fault whether it is normal fault or it is thrust fault, or if it is a strike slip fault, so whether it is left lateral fault strike slip fault, or whether it is right lateral strike slip fault. So these are basically sense of movement. So you, based on the your environment or sense of movement, you can categorize different type of fault. So to categorize the different type of fault, you can add a new field, and you can assign the different nomenclature with the help of that field. So for example, I am just to do that, you can simply write here type and add a new field. So here you can see in field list a new field has been added. So now if I want to trace this fault, a new layer, here you can see this layer is a linear features, and you can start your editing by the enabling the toggle editing option. So here you can see this, with the add line feature you can trace your fault. So here first you have to identify your fault, and then you can start tracing. So here I can see this is my fault. So I would trace the fault with the help of this digitization. So again I am telling you that this is a time taking process, and you have to do it very precisely to accurately mark the all these features, whether it is fault or whether it is the river terraces or any kind of features, geomorphological features. You have to mark it very precisely. So you should first spend some time to identify those features, and then you start tracing. So when you finish your tracing part, you just click the right click with the help of your mouse, and you assign a number. So this fault is the thrust fault, so I will just write the thrust fault. So in the type option, you can categorize your fault based on the sense of movement, or based on the environment. So this fault is the thrust fault, so I wrote the thrust fault in my type. Similarly, if you are confident enough that this fault you can easily identify on your satellite image, so you can categorize based on the whether it is active or potentially whether it is active thrust fault, or somewhere you might not get the clear view of your map, or your surface expression of your fault is not present on the on your map, or you cannot trace the fault in entire section. So in that case you can use the some dotted line, and you can categorize that portion of fault as a different nomenclature. So that also you can do for example, in this portion where I am not getting this kind of fault scarp. So this here I can also categorize this part of the fault as a fault scarp, but in this portion where I am not able to identify the fault scarp. So in this area I can trace the fault, or I can name it as a thrust fault, or as a active fault, or so similarly you can add a new field, or you can also categorize the fault based on the expression. So for example, this fault which I am tracing is basically your Himalayan frontal thrust. So in the Himalaya, so if you have some basic idea about the Himalayan tectonics, so you might know that in Himalaya, so you have the MCT in the northern portion, that is the main central thrust, and then MBT, and then the frontal thrust is your HFT. So this fault system has been developed over the time since the formation of the Himalaya. So it is considered that Himalaya is formed way back in 50 to 60 million year, and since then due to the collision of Indian and Eurasian plate, the different thrust faults has been developed over the time, and due to the forward propagation due to this forward propagation, first the MCT has been formed, that is your main central thrust, and then MBT, the main boundary thrust, and now the present day the active fault which is considered as a Himalayan frontal thrust. So this Himalayan frontal thrust is considered one of the most active fault of the Himalaya. So this part where I am doing the tracing part, so this is your Himalayan frontal thrust. So based on your interest or your area of interest, you might trace the different kind of faulting environment. So you can digitize those fault or the geomorphological feature with the help of this QGIS, or even you can use the ArcGIS, that is also a GIS platform. But you can use this QGIS because QGIS is freely available and a easy handy software to use. So here I trace the fault. So here I can also categorize this as a thrust fault. So now here you can see that I have marked the fault, or suppose this if I want to categorize this one as a scarp. So you can simply go to the your open attribute table, and here you can see that the first ID where I have marked this one as a thrust. So you can select your attribute also. So you just simply you can simply click. So if you have to save these features, and once you save your feature, here you can use this this option. So here this option you can use to select your features which you have marked. So you can see this this shapefile I have selected, and now you can if when you open your attribute table, you would see that this one is the feature which we have selected. So you can, if you want to change the name, so you can directly change from here. Suppose I want to give it the name as a fault scarf. So I can change it from here, and when it changed, you can save it. So now you can see this one is categorized as a fault scarf. So you can do this with the help of the attribute table, and once you have completed the digitization part, you can change the color, and you can also assign the different shapes to your fault or the geomorphological feature. Suppose I want to keep it as a red color, so you can choose the red from here, and here you can see your color has been changed. So now it is selected. To deselect this feature, you can simply click over the deselect feature from all layer. So now you can see this is now deselected. So you can also change the width of this line, because right now it is a linear features. So you can also change the width of this line. You have to increase the width, and here you can see a preview that how your line would look like. So you can change when you are satisfied with the width, you can apply, or here you can see your fault has been marked. So similarly you can use the linear vector file to trace all the linear features or linear structures. So you can use this linear vector file. So now I will give you a demonstration to add location in your map, because adding location is one of the important part, and that you would be able to do with the help of point vector file. So we have learned to trace the feature with the help of polygon, and we also have see that how you can trace the linear feature with the help of line vector file, and now we will see to add the location in our map with the help of point vector file. So to add the location, first you have to add the base map, and because in your base map you can clearly see the location. So in this case we have opened the Google satellite. You can also choose the Google hybrid map. So in this Google hybrid map you would be able to see the different nomenclature of your map. So you can simply close this image, and here you can see you can see the different features which you have traced or digitized. So, with the help of this Google hybrid map, you can simply add the location on your map, or you can nomenclature in your map, because the nomenclature or adding location is one of the important part of any kind of map. So, to do that, you have to first add the layer. So, you can simply go to the layer panel and you can add location. You can save you can give the output directory, and from the geometry type, to add the location you have to choose the point as your vector file. So, you choose the point as your vector file and you press OK. Now, you would see that a new layer with the name of location has been added to your layer panel. You can start the tracing with the help of toggle editing mode, and you can put the layer. So, suppose this is Haldwani, so you can put a point over here, and here you can see you can assign a name 1. So, here you will see the new point has been added, and then another area is this one. You can choose this as a another location. So, similarly you can assign the name of the locations, and once you have mark your point, so you can add go to your open attribute table, and from the open attribute table you can add a new field. So, with the help of this attribute table, here you would see a new option of new field. So, this new field would be your location. So, I want to just add the name of the point which I have just added. So, location would be in the text string, or the you can increase the length, and here you can see. So, the first location you can simply select which one you want to give the name. So, here you can see your point has been selected. You go to your attribute table and you can assign the name. You can save it, and the another name is you choose, select the point, and here you can give the name of for this location also. Now, you save all the point which you have marked. Now, you can close your map. Once you are done with the selection of the location, you deselect your selected point. You can add label to this point to get the name on your map. So, to do that, you have to go to the property, and you would see the label panel just below the symbology. So, on the label panel, by default it would be on the no label option. You have to change it to the single labels. Once you click on the symbol label, you would see you have to change the value. So, because we have saved the name of the location on the location panel, so you have to change it to the location, and once you do that, now you apply, and here you can see your name of the location has been added on your map. So, this the width of the width and the text format, you can change all these things from this using this option. You have to explore all this option to do the these all options are related to the labeling part. For example, the text, from this text menu you can change the font size or font style, or you can also increase or decrease the size of the text. So, all these things you can do from the text option, and from the buffering menu you can create a buffer zone on your map. So, for example, you can also increase the size of the buffer. So, here you can also change the color. For example, if I choose the black, so now you would see that buffering. So, this buffering you can use, or you can also create the mask or background. You can assign a background for your selected label. So, all these things you can do from these options. You have to explore these options, and these all options are related to the labeling part only. So, this by the labeling part you can do the labeling. So, similar kind of labeling you can do also for your others geomorphic feature. For example, if you want to label your terraces, so you can do that by going to the label. You have to first go to your terrace layer, and then you go to the label from the symbology option, and here you have to choose the single label, and from the single label you have to choose the type, and now you click apply. So, here you can see your terraces is also labeled. So, similarly you can also label your alluvial fan surface also. So, with the help of these options you can do the labeling part. So, once you done with all the mapping part, all the digitization part, then you have to go to the print layout map or print layout manager. So, you can go to the print layout manager that is mentioned over here. So, here you can see a new print layout option. On this new print layout option, you would be able or export all your shape files into a map format. So, in our next lab we will show you that how you can with the help of all this vector file you can generate a map in the JPEG or PNG format. So, that we will see in our next lab. In our next lab I will also show you that how I will also give you a demonstration that of a map that we have generated for our research purpose. So, that I will show you, and with the help of that map, because in that map I have traces all the shape files or all the geomorphological or tectonic features with the help of this type of anaclaves. So, I will show you all those shape files. I will generate export or import all those shape file over here on the QGIS, and then I will show you that how you can export that map into a JPEG or PNG format. So, that we will see in our next lecture. Thank you.